Okay, so we said we classify CNC machine based on the positioning system into two types, incremental or absolute. So since it is the machine,
Excuse me, doctor.
yes.
I hear some sound. There's a wind sound, all right?
Okay, wait.
Oh,
I think there is one mic is on. Hadi, please mute your mic. Hadi,
some sound interrupt our class. Listen.
outside.
Yeah.
It's not from my side.
Wait, I'm listening.
Now, okay.
Yeah, okay.
Okay, thank you. Okay, just we start. So we said the CNC machine can be classified based on the positioning system into two types. One, we call it incremental system. The other is absolute system. So incremental and absolute actually is related to the part of the motion of the machine spindle or the machine table. Okay. So when we say the system will move incremental, that means here the system will move from one point to another point based on incremental systems. We will see what is the main difference between incremental and absolute coordinates. Actually, in incremental coordinates here, when we move from one point to another point, the first point will be our reference, and this reference point will not be fixed. Reference point will be changed with the movement of the machines. Okay, but for the absolute system, the reference point is fixed. So this is the main difference between the incremental and absolute. In the incremental, the reference point is not fixed, is moved from one point to another point based on the coordinates here. For example, if this is the first reference point, then the machine is moved to this point, then to other point here. So the reference will not be fixed, it will move. The first reference point is here, the second reference point will be there, the third reference point will be there, and so on. So the last point of the machine stop become its reference point to the next step. We will go to see in detail later on. And for the absolute here, we have a reference point. We select our reference point for the machine. In the beginning, we said our reference point, for example, is 0 to 0. Then all other coordinates will be measured with respect to this reference point. So what is the distance from on x-axis, for example, what is the on y-axis, what is the distance on x-axis and y-axis, all measuring to the reference or to the fixed reference point. So most control on the machine tool here capable of handling both alternate code between G90 and G91. So now we are talking about the G code, and I told you before, this type of code is not like the other language coding. We are not going to write a complete complete code, which more structured. Here the code is represented by some letter with numbers. So you are going to set a list of letter and numbers in line, for example, and each line need to take accomplish or to execute one process or one task by this machine. So for the absolute, if I give this G90, for example, order to the machine or to the CNC machine, the CNC machine directly will understand you need to use the absolute coordinate. So absolute coordinate, if you give G90, G90 means absolute coordinate. It's like a command for configuration of the machine only. Okay, G91, this is incremental coordinate, for example. So later on, when we try to have some coding for the machines or for some machine like a milling machine or lathe machine or turning machine and so on, so we are going to, if we want to use absolute coordinates, so you are going to write in the code G90. So G90 means increment absolute coordinate. G91 means incremental coordinate and so on. So here we start with incremental system. So the position here given from the current point. From the current point, as I told you, your reference will be given from the point that if the machine is at this point, or the spindle or the head of the machine at this point in the beginning, or on the workpiece that I want to modify, or I want to cut, or I want to drill, I make the reference on this point. Then I move to another point. So the current point will be my reference for the next step. Then the current point will be my reference for the next step, like this one. So this will be reference point for this point. This will be reference point for that point, and so on. So what's the disadvantage of this type of systems, of positioning system actually? If you make the if one of these reference is selected wrongly, that means you enter the wrong coordinates for one of these reference, the whole your work will be affected. Because if this wrong, that means that one will be wrong, that one will be wrong, and until you come to the end of the process, all your process will be wrong, because you do not have a fixed reference point. Your reference point is variable, is changed with time, I mean with movement. Okay, so the position of reference will be changed with the movement of the machines. So we said G90 command here tells the computer MCU or machine control unit to be in incremental mode. Okay, later on we will see how we can use this type of coding. So this is an example to show you how we can calculate the coordinates. Usually, why we need the coordinates? We said the coordinate is the most important or a most important system for CNC machine, because always when I am working on a piece or on a work piece or on a product, so I want to cut this product, I want to turn this product, I want to make a hole in this product, and so on. So all this depends on coordinate. Where I want to make the hole, for example, at this point. So I want to know the coordinate from both sides, from this axis and from that axis. So then I want to move to other point, because we said we have some system which is point to point, we have some system which is continuous. So if we want to the machine will move from this hole, for example, to the next step, or to do another hole here on the other coordinates, I need to direct the machine, or to define the axis for the machine, or the path for the machine, how the machine will go through this way. So I gave it the reference coordinate. Then I said, from this reference, move like 1 centimeter or 1 inch to the right, move 1 inch to the top, move 1 inch to the bottom, and so on. So these coordinates actually will help the machine to do the task that is required from it. Okay, so for example, here in the case of incremental systems, if we have this is the first point, the coordinate of the first point from this reference point here is 0.25. Okay, so this is 0.25, for example. This distance on this axis is 0.25, and here we have another distance also on the other axis, which is defined on the top here. Now I want to move from this point to the next point, for example. So this point become a reference for me when I want to move to the next point. So the difference between the second point and the reference point here, it is 0.75. I do not measure the difference from this point to the zero axis. I measure the difference between this coordinates to this coordinate. What is the difference? It is 0.75. Please give me your attention. Okay. When the machine head or spindle at this point, and I want it to move to the next point here, this point will be the reference for the following point. So the reference, that means what is the distance from this point or from this coordinate to the next point? It is also 0.75. We do not say the difference is 0.75 plus 0.275 plus 0.25. No, the difference is only between these 2 points. So I define what is the distance here. This become reference. This will become my target. Okay. Now, when the spindle reach to this point, this point become a reference point to the next point. So the spindle has to move for 0.75 again to the next point. Then the spindle here want to go up. For example, this will be the next target here. So this becomes the reference point. And from the reference point, the machine or the spindle head, the machine head or the spindle need to go up for 0.75 on the other axis. This is one or horizontal axis. It can be X, can be Y, or when we talk about XZ or XY, it depends on what is the coordinate that we are using or what is the axis that we use. So here it go up for 0.75. Now from 0.75 here, this 0.75 become my reference point to the next step. Where is the next step? It is here. So what is the distance, or what's the value from this point to that point? It is 2.25. So it's go by 2.25 on the left axis here to reach to this point. Then in order to again return to the start point, for example, we need to have same 0.75 down here. Okay, so this is what we mean by the incremental coordinates. Incremental coordinates means your current point will be your reference for the following point. Your current position, it will be your reference for the next position. Is it clear? Please, if not clear, let me know now. Faham?
It's clear,
Yes,
Doctor.
yes, Faham.
Okay, thank you. So here for the commands that, or the commands code which tell the machine to move here according to either the spindle or the knee for the on the vertical milling machine here. If you are using the vertical milling machine, for example, we have the knee or the spindle and we ask them to move. So we need to have, if you are going to go to the right, if you are going to the right, you just make plus x. Plus x means if you want +1, +2, +5 to the right axis. So this is the x axis, for example, here. You want to go to the right by 5, so you write just in the code, in the coding of this machine, you are going to write +5, +5, x +5, y +2, y -3. So you are going to define it in this form. If you want to go to the right, so you write +x, for example. If you want to go to the left, you are going to write -5 or x minus x -5, x +5, and so on. So to the right will be plus, to the left will become minus. If you want to go for I mean the cutting tool here to be located towards the column, we said last time, we said we have the three, if we have three axes, so one will be left right, which will be axis x axis, one will be towards or away, either towards to the table or away from the table here, towards to the machine or away to the machine from the machines. So here towards will be plus, away will be minus. So if you have on the y-axis here, you said y +5, that means we are going to 5 towards the machine, or -5, y -5, it will be away from the machine or from the table, the side of the machine spindle or machine head. Then for the Z here, we are talking about up or down. So because we are talking about the spindle or the head here, so or the cutting tool, so we can move up or away from the workpiece. So since for example, if you have, this is the spindle here, and you have the workpiece on this way. So if it's go towards the workpiece, that means it will go down. If it's go away from the workpiece, so it will be up, for example. So this also the same. We are going to use plus or minus. That means in the coding here, after you select the type of the mode of operation, which is G91, which is will be like incremental, then you are going to define the coordinates for the machine to move. So you will say, for example, plus x +5, that means go right by 5, then y plus or y -2, for example, it will go in the y-axis in the away from the machines by -2, and so on. For the absolute system here, all dimensions or position are given from a reference point on the job or on the machines. So if either you define your workspace on the, your reference point on the workpiece itself, the product or the piece that you want to modify, the piece you want to produce, the piece that you want to cut, drill, and so on, or from the machine itself, the spindle of the machine or the scroller or the trail of the machine. So all dimension here from 0 or reference point. We said we need to have a fixed reference point. So if you select the 0, and usually most of the work are selected 0, 0 as their reference, because it's make it easier to to write the program when you start from 0, then you go right, for example, by 2, you go left by -1, you go up by +5, you go down by -2, for example. All this easy to say or easy to calculate. No need to measure this distance because it's by default, you know, this is 2, 3, 4, and so on. If you start from the 0 point, it's easy to identify the coordinates of the points. Okay, so here errors not carried to any other locations. It means that this overcomes a disadvantage of incremental coordinate because my reference point is a fixed point. It's not changeable. So if my reference point is correct, so whatever, if I did a mistake, it will not affect the other point. If one of the hole is wrong, other hole will not be affected. If one of the drill task is wrong, other drill task will not be affected. So the G90 command here will indicate the MCU that to be operated in the absolute mode or absolute positioning system mode. So this is how we define the coordinates by using the absolute system. You have, this is the reference point. So from this point to here is 0.25. From this point to here it is 1. From this point to here it is 1.75, 2.5, 2.75, and so on. So all the position or all the coordinates are referred to the reference point, which is 0, 0. All your measurement to the 0, 0 point. Okay, so for example here, this is, you select this one here. They select the reference point, which is this one is the reference point for the coordinate, which is represent this point here. So they measure from this point is 0.25. From this point to here it is 1. From this point to here it's 1.25. So you select your reference point will be a fixed point that you select. You do not change. As I told you, most of the work they select their reference point like a 0 point, but also it's not compulsory to be a 0 point. You can select any reference point, but this reference point will be fixed with respect to all coordinates that you want the machine to go through, or to all position that you want your machine to go through. Clear? One answer. Okay, thank you. Okay, so when you define the commands for the absolute system here, also the same, you are going to say plus x, minus x, plus y, minus y, plus z, minus z, but all this will become with respect to the 0 point. So if we said our 0 point is 0, 0, so at this point, so any point plus x will be on this side, any point minus x will be on the other side, any point which is plus y will be on this side, minus y will be on the other side, and or plus z will be on the top side, for example, and minus z will be on the other side. Okay. So this is one example to show you how we can define the incremental position and the absolute position. I mean absolute coordinate and incremental coordinate. We have, this is the start point, for example, which is 2020, and we have the end point or the next position will be 40 and 50. Okay, so this is the next point, the second point, and here will be the first point. So in the case that we want to use the absolute position, we need to select our position point, which is the 0, 0 point. Okay, so in the case of the absolute position here, we are going to select our reference position. For example, it is 0, 0 here. So if I ask you now, what is the coordinate of this point with respect to the 0, 0, it will be 20x, 20y. For example, this is the x-axis. This is y-axis here. So you have 20 from y, 20 from x. So both are 20, 20. So this is the first point. What will be your second point with respect to the reference point? Because in absolute, we have a fixed reference. So the second point here is located at x equal to 40, because this is the distance is 40 from until 0, it's 40. Then for the y-axis is 50, because we have the distance to the reference is 50. So this is the absolute point. So here, in the case of the absolute positioning system, the coordinates for this point will be x equal to 40, y equal to 50. So when I program these coordinates into the CNC machine, just I need to write x, for example, plus 40, or sometimes we don't need to write the plus because we already understood that with that plus also still plus, and y plus 50. Okay, so that means the machine will move from 2020 until 4050. So the head of the machine will go to this from the first point to the second point. But in the case of incremental positioning system, this coordinate will not be the same. It will not be 4050. Why? Because these coordinates will be measured with respect to the reference point, which is the first point. The first point is 2020 because our first point, reference point will be 00, for example. It is 2020. Then the machine or the spindle has to move to the second point here. So what will be the coordinates, or how long the machine should move on the x-axis and the machine should move on the y-axis? So from the point of 20 here, the machine only need to move 20 steps to reach to this point on the x-axis. To reach to the 40, the machine need to move 20. From 20 need to move for 20 steps only, or 20 units. Then on the y-axis, in order to move from this point, which is 20, until 50, it needs to move only for 30 steps or 30 units. So for that, the coordinates in the case of the incremental will be x equal to 20, y equal to 30. It's not x equal to 40, y equal to 50, like in the first case here when we talk about the absolute coordinates. So this is the main difference between the two types of configuration for the positioning system in the CNC machines. Okay. So if it's okay, just we move to the next step here. And we said here there's some definition, or culture for rotary position designations. So all CNC machines here to follow the same standard that we mentioned in the last lecture. We want to talk about some definition for the, or some standard for the CNC machines, for CNC machine coordinates or positioning system. So the standard here will define the machine coordinates. That means it will define which will be x-axis, which will be y-axis, which will be z-axis. Okay. Then the programmer here, when he write the program for the machine operation, he can write it without worrying which part in the machine will move. Is it the table? Is it the head? Is it the product itself that will be moved, and so on? It doesn't mean anything. The program is the same, because the program is depends on the coordinates. The coordinates describe how the spindle or how the rotary part of the machine will move along the workpiece. So whatever is the workpiece, is it rectangular, is it cubic, is it square, and so on. So it will describe how the machine move on the x-axis, how the machine move on the y-axis, how the machine move on the z-axis, if it is from 3 axes or if only 2 axes. So it will define the coordinates for 2 axes. So whatever, which part is moved, is it the head? Because we said some machines, the head is fixed and the table is moved. Some machines, the head is moved and the table is fixed. Some machines, the table is, fixed and the product which will be moved. Okay. So it depends here. It doesn't matter which part is movement part, which part is table or fixed part. So at the end, the program will describe the line, the coordinates or the path, how the head should move on the product. Started from which point, go up, down, left, right, and so on. So it doesn't matter which part is the movement part. So there is one rule, they call it the right-hand rule, and this right-hand rule actually is used to define the coordinates for the machines. So if the machine consists of 3 coordinates, for example, like the milling machine, so we have x, y, z. So how the operator or how the programmer will know which part is x, which one is z, which one is y, which coordinate is x, or the coordinate x to which direction, coordinate y to which direction, coordinate z to which direction, and so on. So we need to use the right-hand rule. So the right-hand rule here, as you can see in this figure here. So this is the right-hand rule. Usually you put your 3 fingers perpendicular to each other. So the thumb is perpendicular with the finger here, and with the third finger. If the thumb usually is indicate to positive x-axis, the other will be positive y-axis. This one is positive z-axis. That means if this is positive z, on the other side we have negative z. If this one is positive y, on the other side here we have negative y. If this one is positive x, on the other side we have negative x. So in this, by using these three fingers, you are by your hand, so you can it's easy to indicate the direction of the movement of the machine different parts. So for example, if the x is indicate the table movement, so you just like put your three fingers in these positions, like to be perpendicular to each other. So usually the thumb finger here will be indicate to the right hand direction. So it will be positive x. That means the right will be the positive direction of x, and the left will be the negative direction of the movement of the table, for example, of the machine. And if the y here indicate the position or the positive direction which is towards the head or towards the machine body here, the other direction which is negative y will be away from the machine body or from the machine or the place where the head of the machine is exists. The direction of z will be, for example, indicating the direction to the top or to the up. If it is vertical, for example, it's a vertical machine. So up means positive direction, down will be negative direction of the machine. So this is the we call it the right hand rule. For actually this right hand rule also used in the electromagnetic field when we want to know the direction of the magnetic field or the magnetic field which is generated from the current passing through a conductor and so on. Okay, this used in machining usually, because you have three directions. Usually we have the direction of the movement, we have the direction of the current, we have the direction of the generated voltage in the case of electrical machine. But here these are the three directions that we have. We have direction of the table movement, left or right, so this indicated by the thumb. The direction of the table, when you go toward the head of the machine or award from the head of the machine, this one is the direction toward the piece or award from the piece or work piece that you are going to work on. This is the one part. The second part of this rule also can be used to determine the positive or clockwise direction. Clockwise direction, we said some of the axes may, or some of the machine may have more than 3 axes. That means it has 4 axes or 5 axes. Usually the extra axis here, more than 3, it should be rotational axis. Rotational axis, that means you have x-axis, and around x-axis you have a rotational axis here. The machine also, one direction on x-axis, but around the x-axis also there will be a rotation. It's not a fixed, not a linear x-axis. No, x-axis with rotation. So there is a rotation axis. So you have this axis, we call it A, B, C, which is represent the rotary motion of the machines. How we can find the direction here? Also by using the right hand rule here. In this case, if your thumb indicate the direction of x, y, or z positive, that means if your thumb is indicate, you just like make your hand like the same as in the figure here. So if your thumb indicate the direction of the positive x-axis, so the a-axis will be the direction of the other hands, other fingers. The direction of this finger, which is this way, this represents the rotation of the a-axis around x-axis. If this is the direction of y, so this will be the direction of the rotary like for B. If this is z, so it will be for z. So actually this is the direction here of rotation. It indicates the direction of your fingers as in this figure. Is it clear how to use the right hand rule? To know the direction of the machine, of the rotation machines or the motion of the machine parts. You need to know the direction of the 3 main axes, which is x, y, z, positive here, and also the direction of the rotational axis, which is A, B, C, positive as well. Okay, here are some of the examples to show you how the machines it looks like and how the movement of the table and the spindle will be in which axis and in which direction. For example, we start with the CNC milling machine here. So in CNC milling machine, it has 3 axes here. So as you can see here, the spindle travel along the x-axis. Where is the x-axis here? The x-axis is the red color. This is the x-axis. So this is the spindle here. The spindle will move this way or that way. The movement on the axial movement depends on x-axis here. It will be either left or right on this way. Then the direction of the table, which is in yellow. This is the table here in yellow color. The direction of table will be on the y-axis, and the y-axis indicated by yellow. That means it will be either towards your, if you stand here, for example, if you as operator stand at this point, so this will be towards the operator or away from the operator, towards the spindle or away from the spindle. Okay, so this will be the y-axis, and the z-axis here is designated by the stationary vertical column. Where is the stationary vertical column? Is the blue one, because this is spindle here will be here. It will move there, but also this spindle can be when it wants the spindle to go to this workpiece. This is the workpiece or the product that you want to make to shape or to form the shape or to cut or to the drill. So this axis or this spindle also will move in this direction, up and down, with the z direction here, up and down towards or away from the workpiece of on the table. Okay, so this is for the milling machine. Is it clear?
Yes, sir.
Okay. Next we have here the CNC lathe, and the CNC lathe usually we said it consists of 2 axes, and it's a machine of 2 axes here. So in this case here we have the most CNC lathes have the Z axis is in parallel with the spindle. So the Z axis here represented by the blue color. So here this is the Z axis, and the x-axis is represent the red color in this way. So the x-axis, that means this spindle here will move to this way. This is in the z-axis toward the body, I mean toward the workpiece or away from the workpiece, and also the x-axis will move on this direction here, either left or right. Next is the CNC contour, and the CNC contour milling here, it consists from 5 axes. It's not 3 like the first one. So here we have 5 axes. So the 5 axes here are X, Y, Z, and A and B. And usually A is the rotational axis around X, and B is the rotational axis around Y. Okay, so in this machine here, you can see the rotational of X and Y and axis in relation with the Z axis. The rotary axis for both X and Y are A and B. As you can see the color here, the orange here, the brown one, the light brown, and also the light green here represent the rotary axis and or for the rotary table. So this the head, for example, this the part which is rotating here, and here we have another part which is rotating. So to represent the extra 2 axes in addition to the original axis, which is the 3 axes, X on the red one, which is moved this way and that way, and Z on that way or that way here. So this part will be moving towards or away from the workpiece, and Z here, I mean Y, is represented by the vertical moving up or down, in addition to the rotating bar. If you have rotating bar, so this rotating bar will represent the rotary axis of your machines. That means during movement left and right, also it will rotate clockwise, for example. Not only movement left, right, no, movement with rotating. For that, we call it the 5-axis machine. Here we have the CNC knee mill, and it's a type of the vertical CNC machines. So the vertical CNC machine here also it consists of 3 axes. It's not 5 axes. So you have 3 axes here, and the spindle is moved along the x-axis, either left or right. The I mean the table here will move along the or towards or away from the spindle. So if you can withdraw this part to here, so it becomes far from the machine or from the spindle, or you push it to the machine so it's become close to the spindle or to the rotary axis. I mean to the rotating part of the machines. Then we have the Z axis here, and the z-axis is up or down by using this type of pneumatic, for example, or a hydraulic part, which is push it up or push it down. When push it up, that means it's become close to the head or the spindle here or the twist drill, for example, and so on. So it's become too close, then the machine can perform the task on the workpiece, or it's go away, so it's become the product is become far away from the head of the machine, so no task will be performed. Actually, in the CNC course here, or in the numerical control machines and numerical control system, all the task will be how you make this machine moving or go in the correct path, so the machine can accomplish the task successfully. So it or the path that you are going to draw through your programs to make any shape that you want, it depends on the coordinates for this point. In addition, and these coordinates can be accomplished by defined points and define how the machine will move from one point to another point. I mean, the movement of the machine is the most important part, in addition to the coordinates of the point that you are going to draw or you are going to design for your program. So on the CNC punch machine here is another type of CNC punch machine, which consists of 2 axes here. So press the part is moved on the x-axis, which is the red color here. So this is the one which move either this way or that way, and y direction will be stationary part. So the y direction here, I mean, when x is moved, the y will be the stationary. When y is moved, x will be stationary. But the direction of movement of y axis, it will be also the same, either towards or away from the bar. You can adjust the position, make it fixed, then x become move. Then you can move the way again to other place, then x become movement part and so on. So the part reference here, the part 0 reference, this one of the CNC milling fundamentals. We call it part reference 0 or PRZ. So the PRZ here, we said before you start or you ask the machine to complete any task, either drilling, milling, cutting, welding, and so grinding and so on. So you need to define what is the 0 point. So you come to place this point or this indicator at the reference point. Reference point means last time when we talk about the absolute, we said reference point is fixed. When we talk about the incremental, we said reference point is moved or is not stable. Okay, so here we need to define the reference point, or we call it the BRZ, or the part reference 0 part means refer to the part that we want to like work part or work piece that we want to modify, we want to cut, we want to drill, and so on. So you need to define these coordinates, because it is after you define these coordinates, all your calculation for the path for the machines will be with respect to this reference point. Okay. So the BZR here is defined as the lower left hand. Lower left hand, you can see is on, if we are going to go move on the positive x-axis here, this will be the lower left hand on the top of the stock for each part. So you have a part here, the lower left hand. So for example, here will be your reference point. Then you are going to move this way, up, left, again return to the same point. The advantage of having part reference 0 here. I mean the 0 point, you select it as your reference here. The on the top left corner is the geometry creation is in the positive xy. So when you have the plane, you see this is the plane, we call it this plane, for example, it is x, y. We have another plane, for example, x, z. We'll see now in the plane later on. Okay, x, y, and x, z, and so on. So if you select the BRZ as your reference, which is the 0, 0 point, your geometry or your calculation will be always on the xy plane. XY plane is easy to do calculation. It's easy for you to indicate the coordinates. When I'm working with XY plane, that means I'm working on this plane, for example, here. If I have three, imagine that you have three coordinates, not only two, okay? So if you have three coordinates, for example, I work on this one, XY plane, and that one is XZ, for example, and that one is ZX or ZY. Okay, you have three coordinates here or three plane. So if I select my reference point is the part reference 0 here, which is at this point on the left top corner. So it will be, I'm working will be, or my work will be on the XY plane. XY plane for the CAD or CAM system. Later on, we will see how this will be represented in the 3 dimensions drawings. The corner on the workpiece is easy to find. So the corner here, I mean the corner point, when if you have this is the cubic, for example, and you select, you want to select a reference point for your work, so you take the top left, I mean the lower left top, here, the lower left top is at this point, for example, and this become your reference point. So this point is easy to find, rather than you go to find one point in the middle here, because when you use the corner point, I mean, for example, any cubic, it has how many corners? It has like 8 corners, for example. Okay, so since you have 8 corners, you select the corner point. It's easy to find. No need to go to measure what is the coordinate for this reference point. Just you said this is the left top corner. This is the corner here, and the left top side of the cubic or of the piece. So this will become my reference point. The negative Z here, these are below the surface. So when we talk about the Z, because we have a thickness here, we have length, width, and we have also thickness. So this thickness here, if I work on this top left corner, that means the down of this top corner will be on the Z axis negative, will be under the table of the machines. Okay, this part will be, I mean, the negative axis here will be under the or in the direction under the table of the machines, towards the table of the machines. So you can see here this just to make it clear to you how it looks like in the 3D dimension, and how many blades that we have in the 3 Cartesian planes here. If you have 3 axes, which is x, you can see here x positive, x negative, y positive, y negative, z positive, z and negative. We have here 3 axes. Okay, each 2 axes will represent one plane. So for example here, this is the x axis, with the y axis give you this work plane. This is the gray one. Okay, while the others are, if you select this I mean when you select your top left, I mean the one that we said here, lower left top corner, so that means you are going to work on this xy plane. Xy plane is here. This is xy plane. So your work all will be in this area. Your measurements, your coordinates will be count on this area, like the 2 dimension here, x and y. And this make it easy for you to define the other coordinates, because we used to have such coordinate between the 2 axes, which is x and y. In the G code here, if you want to select this type of Cartesian plane, you are going to use the G17. You see how the code here looks like? The code for NC course is like this one. Just for that, they call it numerical control system. So numerical control system, that means the code here is consists from number and letters. and sometimes characters. So you are going to, for example, G17, if you just gave the command G17 to the machines, that means you define to use this XY plane. Okay, then if you want to use the XZ plane, so the XZ plane here between, I mean the XZ plane between the X-axis and the Z-axis, so you are going to use this side. I mean, which is more depends on the height of the product. So if your product is like this one, cubic one, so it's like you work on this area, on the side. But if you work on X-axis, that means you are work on this plane. Okay. If you want the YZ plane, so this is YZ plane, it's become between the Z-axis and Y-axis, and it gives you like a sheet or a plate, I mean a plate here. So this plate or this, we call it like plane between Z and Y-axis, it will define like you are working on this side of the cubic or on the left side here. Okay, so these are the code that will be used later on. I mean, this is the definitions for the 3 coordinates plane. G17, it gives you XY. G18, it gives you ZX or XZ. Actually, it's the same, ZX or XZ. Y, I mean, here we give you YZ or ZY, which is G19. So here you have, this is the 3 or the 3 planes in the Cartesian coordinate system, which is XY, XZ, and Y.